Hello folks, welcome to Lester's Custom Truck Shop. Daniel in New York. This is your custom SX, our DX959. Showing you the inside of it there. There's your LC5304NX. There's your SX175. And there's how I did the power cable using those half barrel connectors to put the wires together. And I've started doing something different with the protection diode. If you look right there, I have replaced D110 with a 10 amp diode. Now D110 was the I believe it was a 4001 that they used to protect the radio. The problem with that is it was only good for about an amp. It's supposed to blow the fuse because it looks like a dead short if you hook the power cables up backwards. But if you had a higher amperage fuse than what the diode was, if it didn't blow real quick, you could still burn up the runs on the radio, because the diode would fail and open up and allow the negative positive power to be applied to the wrong sides of the power terminals. This guy here is a 10 amp. It'll stay in there a lot longer with the cables reversed, and I'm pretty sure it'll blow the fuse. And I've also beefed up the runs on the bottom around it right there by applying solder to the runs. It's in that area right there. Okay, you can see that one goes to ground, the other one to power. And I made the solder very thick on there. I don't know if you can actually tell it through the camera, but there it is. Okay, got the SWR sense board, the Galaxy SWR sense board removed, and I'm using the SWR bridge that's inside the SX175. Otherwise, you'd just be reading the SWR between the radio and the amplifier, which that don't do you a whole hell of a lot of good if you're trying to install an antenna. The way it's set up now, the radio uses the SWR bridge from inside the amplifier. So you're actually looking at the antenna SWR now when you read the SWR on the radio. The only drawback is that the antenna warning light doesn't work, so you need to be mindful of that. I haven't figured out a way to get that to work yet, really, because I haven't had time to sit down and analyze it. It probably would just take a diode or two, and I'll hopefully eventually figure that out. But for now, you're reading SWR between the amplifier and antenna. That's what will show up on your radio meter. Okay, there's the 15 kilohertz 10.7 filter. See those little blue diodes there? Those are the Schottkys that Galaxy's putting in all of these now. There is your dual final setup. All three of these are IRF 520s, both the driver and the dual MOSFET finals. Got the heatsink installed. I do put heatsink compound between the heatsink and the aluminum on the back of the radio. The only drawback is if you get your finger in that, it gets everywhere. So just be mindful of that. Okay. And let's see. There's your LesComm serial number sticker. Got the new power cable installed. That's what it looks like in the back. Heatsink in from the back. And your serial number plate will be attached to this screw right here. Okay. Now again, I'll put these back on there simply for the manufacturing date and the manufacturing serial number. If I can get this thing to focus. But the FCC certification, the FCC ID M38 DX959 is void. Once I do the modification to these radios, this radio is no longer Class D certified. It can legally only be used on 10 meters. Okay, so you need to have a ham license for that. Even though it covers below CB, pirate bands, all that stuff, legally you can't talk in that area, and you can only legally talk on 10 meters. Okay, I've warned you, I've told you. All right, and this one, this chip here, had address 0, so we actually go to the lowest channel on this one. Didn't have to change out the chip. It's funny, some of them have that, some of them don't. It just depends on which chip they threw in there. And the new voltage regulators that Galaxy's putting in here, you don't need to upgrade these. They've already upgraded them. They have much higher amperage than what the old bipolar voltage regulators were. So that one is an 1827, and I can't quite read this one. It's an 18 something. Thought it was an 1859 or 69. But anyway, I checked out the specs. The specs are much higher than what they used to be on the other ones. I think the other one was an A1012 that was in this spot. And that one was a 857, I think. I can't remember. Don't quote me on that. That's probably wrong. All right. Okay, let me get the faceplate put back on it. Just finished gluing the lenses in it. Was waiting on the glue to dry. But there's the faceplate. And I'll get that put back on here in short order. I'll be back. Okay, Daniel in New York. This custom DX959 is yours. Okay, there it is. Now let's get some power readings. The meter on the left is the average meter. It has a 100 watt slug in it. The meter on the right is the peak reading meter. Right now I have it set on the ×5 scale. So we're going to be reading from this top scale up here. That's 200, 225, 250. Okay. This one will be reading on the bottom scale. There's 100 right there. 80 and 100. Okay. This meter is on ×5. This one is just whatever the slug has in it. Okay. The slug is set for 100 watt. It's got a 100 watt slug in it. And you can see right back there, there's the remote thing with the slugs in there. Okay. Now the RF power is turned all the way up. I'm on AM on channel 19. You can see we're dead keying about 60 watts. Audio. Over 250 watts peak. ×5 is as high as that meter will go. Alright, now I'm going to switch to, well actually, let me turn the RF power all the way down. Okay, you can see we're about 42 watts on average. Audio 1 2 3 4 5 5 4 3 2 1 1 2 3 4 5 5 4 3 2 1. Bouncing right around 200 225 watts there. Okay. Now let's go to lower sideband. Still on channel 19. I am on the dummy load. Hello, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Audio. Wow, you can see the average power was about 100 watts. And again, peak is over 250. That's with power turned all the way up. I'm going to turn the power all the way down now. Audio, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Audio. A little over 20 watts average and about 125 on peak with the power turned all the way down. Okay. Now then, operation of the radio. First, let's do the channel select switch, or the CSS switch. With it all the way over to the left, the channel selector changes the channels, okay? With the switch in the center position, or all the way to the right, changes bands. See that? That is your highest frequency right there, 28605. That is your lowest frequency, 26695. All right, let's go to the CB band. Our channel 5A, I'm going to switch back to channel selector, or channel 15A. All right, I'm back in the channel position. And the differences, see that last digit right there? How it goes up and down as we move up and down the band. The problem is that 10.24 megahertz reference oscillator that the radio uses to space the channels exactly 10 kilohertz apart. If it's not exactly 10.2400 megahertz, you wind up with differences on each end of the band, okay, and that last digit will move around a little bit. But you've got plenty of room on the clarifier, okay, like we're on 19A now, 195 is center. We can slide down to 189, which gets you the 0. And you know what, let me go to channel 40. That way, or channel 38. A lot of you talk sideband on channel 38, okay? Now then, we're on 385. Let's switch to lower sideband. Now, on lower sideband, it will slide all the way down to 377 from channel 38. So to get to 380, you slide down to about right there. See where the thing is on the clarifier there? But the nice thing about the slider on this radio, you can go the other way too. It goes all the way up to 393. Okay, right there is 5 kc up. And that's center frequency right there with it pointed at the R. All right. And let's see, what else did I want to show you? Okay, let's do these squelch scan. First, you set the clarifier. I'm going to leave it on lower sideband so you can hear the static. I'm connected to the dummy load. That popping noise that you hear is my soldering iron switching on and off to keep the temperature set. Took me a while to figure out what the hell that was. Okay, now I got it squelched. I'm going to hit the up button, and away she goes. Now I'm going to unsquelch it, and it stops. Now you notice the first channel that it shows up there was 050. That's the channel, the last channel that was stored in memory, but as soon as it reads this one, it starts reading the correct one, 051. So just remember, the first time it does that, it's going to have the last channel, and then it will update the next cycle. Alright, and that's what it does when the squelch is open. Usually the squelch would open when you're receiving a signal. Okay, and once the squelch closes, it goes back to scanning. It does the same thing going down. Okay. There you have it. Now, if Squelch scan is on, you can't use the CSS switch. If the CSS switch is in band position, then Squelch scan doesn't work. Okay. RF power. All right. Hello, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. You are seeing the meter dim a little bit. That's normal. It's pulling about, what is that? Audio, about halfway between 15 and 30. So about 22.5 amps at full power. So you need to have a good stout power supply, okay? All right, well, there it is. There's your SX175 on the bottom. Okay, your new decal on the face. Of course, I got the protective tape on there. Make sure that you peel off the protective tape. Don't leave it on there too long. Okay, there's the side of it. There's your new, not new, there's your FCC plate with the serial number and date the radio was manufactured. And here's the LesComm sticker. Back of the radio there, your heat sink. Only thing I got left to do is put the warranty stickers on there and box it up. Should go out tomorrow. Okay. Thanks a lot for your business. It was my pleasure to build it for you. I certainly hope that you enjoy using it. 73s.